So yeah, I'd like to talk about two different worlds. So one world is basically data analysts or people working on big data or data sources, transforming them, filtering them, presenting them in some form. And these people tend to work in Python. You can also work in R or other languages, but Python is a very popular environment here. And on the other side, we have people thinking in business terms. They think about KPIs. They think about decision making, and they tend to use spreadsheets a lot. And I've seen that in my career, and I want to talk about that today. So my name is Chris Lafra. I am the founder of PySheets. I used to work at technology companies like Google, IBM, and Uber, but I also worked at financial institutions like Morgan Stanley, Bank of America, and JP Morgan. And in all these places, we solved the same problem, big sets of information that needs to be filtered, transformed, and repurposed. The different goals for the data, of course. In finance, you want to do proper risk management or asset management or calculation of prices. And you want to get the best prices or the fastest prices so you can be faster than your competitors or better. In something like Google, you're more interested in seeing the world as a graph and then finding relationships between information and rendering that really fast. But in the end, it all comes down to the same problem. So these two worlds that I mentioned, so we have spreadsheet people on one side and we have Python people on the other side. They don't talk to each other very well. Let's put it that way. I've seen that at the big banks where I worked, but it's also quite known, right? Python programmers that have to deploy applications to production have to worry about versioning of the data. They have to worry about scalability. They have to worry about code reviews. So all these things make them focus on really the solution rather than the problem. Whereas people in the business, they just think about the problem. They think about how to express relationships between information. They can write functions in spreadsheets very well. They're not, they're smart people, let's put it that way. But as soon as they see a Jupyter notebook, then they shut down. Yeah. So I wanted to solve that. So what we're going to look at is a proposal that I have, and it's one of the many. Like, you can solve the problem in many ways. You can start from the spreadsheet side and add Python support, and then get to something like eventually Python in Excel, which is an offering from Microsoft at the moment. But you can also start at the Python side and see, like, how can I render the information to the end user? So you end up writing data analytics packages like Pandas or Polars or DuckDB. And then you end up with sort of presentation layers on top, visualization layers. So the previous talk in this track was on Panel, which is one example of, basically trying to visualize the information into a format that people can basically have actionable results a little bit easier than just looking at numbers. So I'm going to do a demo, and then I want to spend all my time there. And if I have time left over, I can still talk about it. But I think the demo is way more interesting than just me talking. So why did I build it? First, there are a couple things coming together. So I mentioned notebooks. Notebooks tend to be linear. But what I saw at Bank of America and JP Morgan, where we have huge trading platforms written in Python, is we love DAGs. So we love dependency graphs. So directed acyclic graphs. And spreadsheets are a great example of that. On the other hand, we also love Python, because Python is a great language for expressing these relationships in your data. And when Microsoft came out with Python and Excel, I thought, like, that's for losers. I can do better. I can do Excel in Python. And I wanted to prove that it was possible. So I wanted to write a spreadsheet in Python like Excel, but it's very limited in its features. So it looks maybe more like Google Sheets. And then it runs in the browser entirely. So I do not want to run on a server somewhere. Now all the code runs in the browser. So for that, I needed to use PyScript. And PyScript came out a couple of years ago from Anaconda. and they're sponsoring the open source project for this. And it makes it really easy to run PyScript or Python in the browser. So I combined all these thoughts and I wanted to basically build a prototype. And here's the demo for that. So I'm going to switch to my demo. So when you, as a first user, whenever you go to just the PySheets URL, you will actually see the About screen. So this will explain to you what is PySheets. There's a pitch deck, there's some examples, but there are also buttons to try it out. So now when we press try, for instance, this will open up PySheets and it runs in the browser. So what you see here, this UI, it's an application basically. This UI is generated, written entirely in Python. So there's Python code that goes to the database that runs in the browser, retrieves all the existing sheets and shows a preview of it. But the code to render all of this, like this menu bar here, for instance, this is all written in Python, and it runs the same way that JavaScript runs in the browser normally. I will refresh this a couple times because I want you to see how responsive this is. This is, very fast. This is coming off a remote server. In each refresh that I do, so I'll do it again, I'll click refresh, and then that's like within a second, right? It downloaded the Python, MicroPython VM, starts it up, it installs all the packages that are needed. Then it loads my main.py and it starts rendering this application. And then the whole thing renders like in 100 milliseconds, including bringing up the entire Python VM. So this is we've moved along pretty far from demos that you may have seen from PyScript like 2 or 3 years ago. It's extremely fast these days. So that's what we have here. So I'll do another example, which I said try, but you can also do learn. And this will take you through the tutorials for PySheets. So I'll do one here, which is based on data. And when you click on this, it will render the sheet. So you saw how fast it was. Like, I have to emphasize this because that's a major part of PySheets is the focus that we have on performance. So I'll close the tutorial, but normally you would follow the tutorial. But here I just want to show what's happening here. So what we have here is a rule written in Python. So this is Python code because it starts with an equal sign. And that means that to calculate the value of this cell, like normally in a spreadsheet, that would be like things like add A1 with A3 or something. Here you can run arbitrary Python code. So that's very important. So in this case, we say get a sheet from A1 to C4. So now we basically have what is called a pandas data frame with 3 rows, and it represents this information that I said. So I showed a dependency graph, which is very important because now you can see the lineage where the data is coming from. And this is like the difference with Jupyter Notebooks, where you just have linear text and you have to sort of remember all the global variables and keep track of that. And that's something that PySheets wants to reduce, that sort of mental overload that you normally have to keep track of. You can also make cells depend on data frames, for instance. So this chart here that we have, which is rendered by matplotlib, but you can also do Seaborn or the libraries. This is actually rendered from that data frame. So if we click on this function here, let me undo that edit here. This is, I didn't want to do that. So here we can see it says it takes whatever is in C10. So that is that data frame. So you can refer to other elements in the sheet by their location. And then you basically make an API call on that. That's the pandas data frame call. And you say plot, and you want to have kind bar, but you can change this as well. You can say bar h. And then I say run script again, and now it's horizontal. So this is how quickly you can like take data and repurpose it or reformat it in another way. If you don't know how to do this, what you can do too is ask the AI to do it for you. So C10 is our data frame. So there's a button here in the top row here. Then we can click, and it will generate a prompt, which is given to OpenAI. And you can see here this code was generated by an AI. And it produces a different chart of the same information, right? There's various ways that you can dimension the data. You can do bar charts, line charts, whatever. And maybe you don't want a figure, you want a pie chart. So you say pie chart. So now I'm changing the prompt. So even if I don't know how to write the Python code for this, I can write English, right? I can type in what I want. So I will generate the code again. And this went to the ChatGPT server, ran this prompt, and this generated this code, which is copied literally to produce this particular view. So that is one way, and the AI generation is a very important one. So I want to actually showcase a little bit more that we can do with that. So let's assume that we want to analyze. So I'll open up an empty sheet. You can see it's totally new. And what I want to visualize is the highest airports in the world. So these highest airports, they have a height, and first I need a data set of all the airports in the world to start with. Now there happens to be one, a training set for data sources, and it's called Airport Codes CSV, and it's hosted on GitHub. And you can see there's about 81,000 rows. So I'll load this one into my sheet as a data frame. So I said import as data frame. And what I have here now is a couple rows, 81,000, and you have columns, elevation, feet, and if we look to the right, there's a coordinates one. So now what I want to do is I want to say, visualize this into a map. Now I don't know how to do that, but there is a package called Volume in Python. And with that, I can reload my sheet. And now it has actually support for drawing maps. So you can add any package that is available on PyPy or that is prepackaged by the PyPy team, and it runs in a worker inside this application. So I have two VMs running. So one is the MicroPython VM, which does the UI. And then there's another one. This is a worker that runs as a web worker, also in the browser. So it's not a remote kernel, but it runs locally. And I'm going to try and produce this kind of code. So I want to say visualize the existing data frame in A1 using Volume, use the elevation feet column, right? That's this one here. And select the airports that are higher than 14,000 feet. So that's the ones I'm interested in. And there's this column, the locations, the coordinates. And I know Volume likes let long coordinates. This is how it renders things. So I gave a hint where it could find that. So coordinates are comma separated. So when I generate the code for this, it'll go back and come back with some information here. And it's actually trying an A1. So I think I moved my code. It's not an A1, it's in E3. So I have to say it's in E3, generate the code again. And this doesn't work. Let me refresh. Normally when I run my demos, I put the data in A1. So this is why it was not rendering. All right, let me try. Okay, clean sheet. We start over, we say import. We use the same data set. We load it as a data frame. And let me try when it's in A1. That should be working better. So generate a code for A1. And this brings up the map here. So now it worked. The airports are shown, like a few in South America and a few in, around the Himalayas. But I want to make it actually visible. So I look at the code that is generated, and you can see here, this Python code I could never write, even though I've been writing code for 30 years. I don't know these APIs, right? So this is why the AI is so important and helpful. But if I change this into 1, it would be better. So I say set the start zoom at 1. Let's see what happens when I generate their code. So ChatGPT goes back and writes again, and now we get 1.5. I said 1, right? So 1.5. Now I can change the code myself as well. Of course, I can fix it and run it again. And this is my end result. So with a little bit of help, with a lot of help from an AI, I can now visualize this information. And this can actually be used in a report directly. You can send it with emails. And there's surprising information here, like in Tibet, makes sense. But I never actually knew that airports in Peru were this high. So these are the 4 in Peru. So now I know these are actually high airports. So that's, yeah, a quick demo of PySheets. So it runs in the browser. It is implemented as a Python application that runs in the browser because it uses PyScript. It has 2 VMs, one MicroPython that starts really fast to render the UI. So let me refresh this and you can see, so this is a refresh of the entire app. It is sub-second refresh and it comes from a server remote, so not on my local machine, so I'm not cheating. So that is, yeah, a lot of emphasis that we want to make it really fast to come up with an iteration on your model. You want to get some information from data. You want to combine different data sets and filter them, sort them, and come up with sort of information from that. So let's go back to the slides, finish off. So I mentioned it's running locally with 2 VMs. That's enabled by PyScript. And PyScript runs on top of PyDite and MicroPython, which leverage WebAssembly, which is the underlying technology. Big thank to Anaconda because they're sponsoring the PyScript project. Without them, yeah, all of this wouldn't be possible. Storing locally is also an exercise that I went through. First I had a remote database on App Engine, but customers said like, well, we can't use App, we have to use Mongo. So it took me like an hour to actually rewrite PySheets to work with MongoDB because I used Kodi. So SourceGraph Kodi is a plugin for VS Code to write your code. We use Cloud, so Sonnet, and the whole process within a day, I could actually go to local storage. So what I want you to do now is actually go to PySheets.app, try it out, try the tutorials, run through it. It's an open source project, so you can install for free, pip install PySheets app and try it out locally. So with that, I overran, I think.